So we're now on question 3. A, given that z is equal to 1 minus I and z2 is equal to negative 1 plus I root 3. Find z1 divided by z2. So still is 1. This is 11, 20, 21. We are now on question 3. Question 3a. So we're given z1 is equal to 1 minus I, z2 is equal to negative 1 plus root 3I. Find z1 over z2. This is 1 minus I over negative 1 plus root 3I. So always when dealing with complex numbers, if you see I in the denominator, then it calls for conjugation. So this should be equal to 1 minus I multiplied by negative 1 plus. So as we conjugate, we use minus. So negative 1 minus the root of 3I over negative 1 plus root 3I multiplied by negative 1 minus root 3I, which then becomes 1 multiplied by negative 1 on top, we get negative 1 minus root 3I, and then negative I multiplied by negative 1, we get plus I. Negative I multiplied by negative root 3I, we get positive root 3I squared over negative 1 times negative 1 down, we get positive 1, we get plus root 3I, then we get minus root 3I, then we have root 3 times root 3, it will give us minus 3I squared. But we know that I squared is just minus 1. So we have plus I minus root 3 there. Down also we have 1. This will give us 0. So we have plus 3. Giving us negative 1 minus root 3 common without I, and then plus 1 minus root 3 if we factor out I, divided by, you can put 4 here and put 4 here. So this becomes the solution. So what we've done here is we want to put the right terms together. The numbers without I together over the whole denominator. The numbers with I together over the whole denominator 4. So short, we factorize I there in for good representation of the solution. So this was A part 1, then A part 2. A part 2. If Z is a complex number, solve Z1 plus I over, there's no Z1 here. Solve Z plus I, solve Z plus I over Z plus 1 is equal to 2 plus I. If Z is a complex number. So here we are solving for Z in short. So you make Z the subject of the formula. So how do you make Z the subject? The first thing is you put over 1 here, then cross multiply. So you do cross multiplication so that you get Z plus I is equal to 2 plus I multiplied by Z plus 1. And this will give us, on the left is 2Z plus I. On the right, we expand 2 times Z, we get 2Z, and 2 times 1, we get 2. Then I times Z, we get ZI. Then I times 1, we get I. So what do we get out of this? We put all the Z's together. So we take this the other side and this the other side as we move I the other side. So we have Z minus 2Z minus ZI is equal to 2 plus I minus I. The I on the left goes there as minus. So that we get Z minus 2Z, we have minus Z, then minus ZI is equal to 2. Because I minus I there will give us 0. Remember, we're solving for Z, so factor out Z, and then we'll remain with negative 1 minus I is equal to 2. Then we divide negative 1 minus I, we divide by negative 1 minus I. So what we have now is Z is equal to 2 over negative 1 minus I. So we conjugate the top by negative 1 plus I, the down by negative 1 plus I, giving us negative 2 plus 2I over positive 1 minus I plus I, negative I squared, which is plus 1. So this becomes negative 2 plus 2I over 2 from down. Dividing by 2, we get negative 1 plus I. So this becomes our solution. So the key thing was just to make sure that you make Z the subject. And then you find it as a complex number. So it is a complex number, negative 1 plus I. Very nice. The next question is B. Rationalize the denominator. 1. 3 plus the root of 2 over 3 the root of 2 minus 1. You can write this as 3 plus root 2 over negative 1 plus 3 the root of 2. So that we don't change what we know. We know that to rationalize, you change the sign of the root. Minus 3 root 2 over minus 3 root 2. So now you multiply, we have negative 3 minus 9 root 2 minus root 2. And then the 2 times root 2, we get 2. 2 times 3, we get 6. Over negative 1 times negative 1, we get positive 1. Negative 1 times negative 3, we get positive 3 root 2, and negative 1 times 3 root 2, we get minus 3 root 2, and then 3 times negative 3, we'll get negative 9. Then root 2 times root 2, we get positive 2, giving us negative 18. So that altogether, we have negative 9 when we add these two, and then minus 11 root 2.
Sir, for example, if we had rationalized 3 root 2 minus 1, it has become 3 root 2. Is it okay?
It has become 3. Where you use 3 root 2 plus 1.
Yes.
This one would still give us a solution. So it will still be okay. So I just wanted to keep what we know by arranging and then change the sign of what we know that we must always be changing. So this one here gives us 0, and then we get negative 17. We get negative 17. Upon evaluation, we have 9 over 17 plus 11 over 17 multiplied by the root of 2. So we have rationalized the denominator. What about this denominator here? For 2 over 3 minus root 2, 1 minus 2 root 3. How do you rationalize this? So you say, okay, this is 2 over 3 minus root 2, 1 minus 2 root 3. And then when rationalizing, you pick 1 here. So let's start with the 1 minus root 2. So we'll multiply the whole thing by 1 plus 2 root 3. And also top, we multiply by 1 plus 2 root 3. When you multiply, we'll get 2 times 1 on top. We'll get 2 plus 2 times 2, 4 root 3. Divide by, we keep this. 3 minus root 2, which we multiply and expand here. So 1 times 1, we get 1 plus 2 root 3 minus 2 root 3, and then minus 2 times 2, we get 4. With 3 times root 3, we get 3. So together we get 12. Because then we simplify. So we have 2 plus 4 root 3 over 3 minus root 2, and then 1 minus 12, we get minus 11, because this is 0 here. So now this is the same as 2 plus 4 root 3. We're now conjugating the down part, so we keep negative 11, multiply 3 minus root 2, multiplied by 3 plus root 2, and then on top, we have 3 plus root 2, giving us 2 times 3, we get 6, plus 2 root 2, plus 4 times 3, we get 12, and 3, and then we get plus 4, root 3 times root 2, we get root 6. So root 3 times root 2 is the same as root 3 by 2, which is root 6, over negative 11, and then 3 times 3, we get 9, 3 times root 2, minus 3 times root 2, minus 2, then 6. So now just write which is 2 root 2. There's nothing to be simplified on top here. Plus 4 root 6. Then we say over. So this is 0 here. Then 9 times 9 minus 2, we get negative. We get positive 7. So then multiplying positive 7 minus 11. So we get negative 7, 7. So what have we rationalized? We would have rationalized the denominator. If you expand, you may think there's even a very serious mistake. Because if you expand, you have like something like the numerator with 3 roots there, different all of them. So if you start rationalizing one by one, you will find a very big thing. So you face serious challenges there. So you don't expand, you just rationalize each bracket and then get back. Then you see irrational numbers vanishing from the denominator. Okay, any questions?
Excuse me, sir.
Yes.
Sometimes I do get confused, like I fail to differentiate when it is root 3 times root 3. And in expression also where it is root 3 plus root 3.
So if we say root 3 plus root 3, here is just counting how many root 3s are we able to see. We are seeing 2 of them. So say this will give us 2 root 3s. So you add their coefficients. So because you know the coefficients of each root 3 here, as we can see, is 1. So we add 1 plus 1, we get 2 root 3. But if it is a product like this is the same as 3 by 3 inside. So we end up getting 3. Because you're saying root 9 and the root of 9 is 3. Or by the definition of the root, the number to be multiplied by itself. Get the number is the root of that number.
All right.
Okay. So this was quiz 1 from one group, of course. Remember that these quizzes they were different a group as it is this coming week. So next week, you also write the quizzes in groups. So in lecture groups, not tutorial groups. So in each TG that you are in, make sure that you have the timetable for the lecture group. I know you guys don't attend lectures, but you should know the timetables. Then I'm sure there will be an area of communication where we'll get to know all of us that it is in this lecture group, it is on Thursday, or it is Monday, or it's when. And then that hour, make sure that you spare time. You need to be here on campus. Sit for that. So for group J, anyway, it's an hour thing, but most likely it might be Thursday, because Thursday there's a 2 hours lecture. So if we go for Thursday, those who are coming from midway, prepare for transport there because you have to go back a bit late. But if you're moving as a group, it becomes easy. So please make sure to get to know your lecture timetables and keep in mind that these quizzes will be written in lecture groups. That is clear?
Yes, sir.
Okay.
Yes, yes, wait.
So the quiz is just on sets. The quiz is hello? I can't really get you.
Why is the root 3 minus 3 root is 0?
Hello? Network is really breaking. Hello? Okay, you can inbox me on WhatsApp. Our students come. So we're ending here. I'll send a paper that we revise tomorrow. That is test 1A, because the whole test 1 is based on sets. So
Sides from Satan.
it's just sets, like when you say sets, up binary. So simply the whole thing should work.